Hi, welcome back. This is Mr. Peck here. Now we are still in the subtopic work done, and this is our second questions. Let us read this question together. A block of mass 10 kg is pulled up a plane inclined at 30 degree with the horizontal for a distance of 5 meter by a force of 120 Newton, which acts along the plane. If the coefficient of kinetic friction is 0.4, calculate the work done by the gravitational force, the energy lost to overcome the friction, the work done by the force 120 Newton, the work done by the normal force, the total kinetic energy of the block after 5-meter displacement, and the velocity of the block after it has moved 5 meter up the plane. Okay, basically this is a block on an inclined plane, and that plane is a rough surface because it gives us the coefficient of kinetic friction. Okay, and there are several forces acting on the object, and we need to find the work done for each of them. Okay, and then to calculate the total kinetic energy after the displacement, means the final kinetic energy, and also the final velocity. So to do this question, first of all, just like chapter 4, we need to draw the free body diagram first. Always start with drawing the free body diagram to show all the forces acting on the object. Okay, so this is the block on the inclined plane at 30 degree. So this is the free body diagram. It has shown all the forces acting on the object. It has the normal force perpendicular to the surface. It has the external force 120 Newton pulling the block up the plane, and it has the weight directly downward, the weight mg directly downward, and also the friction opposite the motion. Okay, friction down the plane oppose the motion. Okay, so these are the forces acting on the object. We must draw first the free body diagram, and the information given is the external force 120 Newton. And we have also the displacement. Okay, please, for this chapter 5, instead of drawing the acceleration, we draw displacement. We draw the displacement. We must draw the displacement beside the free body diagram because we want to calculate work done. Because work done has included the displacement. Work done equal to Fs cos theta. So it has the displacement. So free body diagram, please include the displacement. We include the displacement because we want to get the value of angle theta. Yeah, because the theta is the angle between the force and displacement. All right. Okay, information given is the mu k 0.4, mass 10 kilogram. All right. Now the first part, what is the work done by gravitational force? Okay. How to calculate? So we use the formula W equal to Fs cos theta. Yeah, it's a dot product. F dot S equal to F dot Fs cos theta. Okay, because we have learned that earlier. Yeah. So work done by gravity. It say ask for work done by gravitational force. So we label the work done as Wg. Wg. Work done by gravitational force. And the force is the gravitational force or the weight mg. So F is like F dot S. This time our F is mg dot the displacement. So I have drawn. Okay, you redraw the diagram. We only draw the mg and also the displacement up the plane. Only draw these two. Okay, so easy for us to get the angle theta. You see, so the mg is directly downward, displacement up the plane. So from here we can easily get the angle theta. Okay, so we know that this is 30 degree. Adding with another 90 degree here. See, here is 90 degree. So the total angle is 90 plus 30, which is 120 degree. between the weight and the displacement. Okay, so then we can solve the questions. Mass is 10 kilogram, G is 9.81, displacement is 5 meter, and then cos 120. Okay, 120 degree. Sorry, yeah. Please rewrite that. Okay, it's a bit messy. Cos 120 degree. Okay, and for that we calculate, we will get a negative 245.25 joule. That's our work done by the gravity. Okay. Now, for the next part, what is the energy loss to overcome the friction? Oh, now we want to find the work done due to friction. So, work done by friction, we label as W friction. Okay, kinetic friction. So, now this time the force is the friction. So, it's friction dot displacement. All right. So, it's change. We got friction dot displacement become friction displacement cos theta. Okay. Before that, we don't have the friction. We need to calculate the friction. So, how to calculate the friction? We have the mu. So now how to find the friction? What's the formula for friction? Friction is equal to mu kn. Okay, friction is mu kn. We have the mu, but we don't have the normal force. So how? Okay. So to get the normal force, first we need to resolve the mg. Okay, resolve the mg. So we resolve it. Okay, and here we have this part is mg cos mg, because adjacent to 30 degrees, so mg cos 30, and this part is mg sine 30. Okay, so what is n equal to? N is equal to mg cos 30. Okay, n is equal to mg cos 30. Okay, then we could just substitute inside all the values. The mass 10 kilogram, cos 30. So we will get this one 84.957 Newton. That is the normal force. Now let's calculate the friction. 0.4 times the normal force we get, and we will have 33.983 Newton. That's our friction. Okay, that's our friction. We got it. Yeah, you have to find the normal force first. Okay, now once we got the friction, we need to get the angle theta. So what's the angle theta between friction and displacement? Displacement upward. So we need to compare between these two. So between friction and displacement, it is 180 degree. Okay. So now let's substitute. So just now friction is 33.983. Yeah, put inside. 33.983 times the displacement is 5 meter. Okay, we got it. Yeah, displacement and then cos 180 degree. And then of course we know that cos 180 is equal to -1. Okay, cos 180 is -1, so we got negative 169.915 joule. That's our work done due to friction. Okay. Anyway, you see the work done by gravity is negative. Work done by friction also negative. This means that both of these work done will slow down the object. Negative means it will slow down the object or decrease the kinetic energy of object as the object move up the plane. Okay, the negative means it decreased the kinetic energy. Now, next part is what is the work done by the force 120 Newton. So we draw the force, work done by external force, 120 Newton. Okay, this is actually the 120 Newton. 120 Newton. So yeah, force. This force is parallel to displacement. Yeah, this force is parallel to displacement. So what we say about the angle theta? The angle theta is 0 degree because they are same direction. So now let's substitute inside. We have the force 120 Newton, displacement 5 meter, cos 0 degree. Okay. So cos 0 is equal to 1 actually. Yeah, cos 0 is equal to 1. Now, so after we multiply, we get 600 joule for work done by external force. This one, work done is positive, means a positive work done will increase the kinetic energy. Yeah. So maybe we write down. Yeah, this negative means the kinetic energy will slow down. It will slow down object. Friction also it will take out the kinetic energy. Will decrease the kinetic. But when you have a positive work done, this kinetic energy will increase. Will increase the kinetic energy. And lastly, we have the normal force. Calculate the work done by the normal force. Okay, let's draw the normal force. The normal force and the displacement. So as we can see, the work done also labeled as Wn, work done by normal force. The normal force dot displacement, or ns cos theta. Now we have this diagram, we can get the angle theta. So for this one, the normal force and the displacement is 90 degree. The theta is 90 degree between normal and displacement. So, it is cos 90. Cos 90, what do we get? Cos 90. Cos 90 is 0. Cos 90 is 0. So, in the end, anything you multiply by, anything you multiply by 0, you get 0, isn't it? So anything multiplied by 0, you get 0. So this one is 0 joule. So this means that 0 work done does not increase or decrease the kinetic energy. Okay, it does not do any work at all. Okay, no work done. If so, when the angle theta is 90 degree between the force and displacement, it will have 0 work done, no work done. Okay, work done is maximum when cos 0, or we can say force and displacement, they are parallel, same direction. And this one, you have maximum work done. If 90 degree, you have 0 work done. Okay. Now, then we have the E. What is the total kinetic energy? What is the total kinetic energy of the block after 5 meter displacement? Okay, so we want to find the final kinetic energy. Final kinetic energy, we use the work energy theorem. Yeah, work energy theorem. Or work energy theorem is the net work done or total work done equal to change in kinetic energy. Change in kinetic energy means final kinetic minus initial kinetic energy. Okay. So first of all, let us find the net work done or total work done. Total work done means we total up all the work done. Yeah, we have work done by gravity, friction, external force, and normal force. So we total them up. So it's W gravity plus work done by friction plus work done by external force plus work done by the normal. So we total them. So we have just substitute all the information we got just now. Right, plus the friction is negative 169.915, negative 169.915 plus The work done by external force is 600 joule, 600, and the normal force is 0. Okay, so we total them. We got a positive 184.835 joule. Okay, so the total work done is positive. Positive means finally it will increase the kinetic energy as a whole after all the work done. The kinetic energy of the object will surely increase because it has positive work done. Yeah. So we use the work energy theorem and we can find the final kinetic energy. Okay, so the net work done equal to final kinetic minus initial kinetic. And we get, just substitute back the information, 184.835 equal to the final kinetic minus, okay, because initially it is not moving. The object initially is not moving. So we can say it is at rest. Initially, the block is at rest, so it has 0 kinetic energy. Okay, so initially, the kinetic energy is 0. This work done is actually the kinetic energy gain. So the final kinetic energy is actually equal to 184.835 joule. This is the kinetic energy gain by the object, the final kinetic energy. All right. Okay, then we can find the final velocity already. Yeah, final velocity. So we just equate this equal to half mv square. So 184.835 equal to the mass just now is 10 kilogram, isn't it? Yeah, the mass is 10 kilogram, yes. So the velocity is equal to 6.808 meter per second. So that's the final velocity. Yeah, once we got the final kinetic energy. Okay. Remember, to calculate the work done for each of these forces, remember first we draw the free body diagram, and then we draw separate diagram for each forces. We have the mg with displacement, we have the friction with displacement, we have the external force with displacement, and normal force with displacement, because we want to find the angle theta. And we just apply the formula W equal to Fs cos theta. Just substitute the angle and the forces, and we can get the work done for each of them. And the total work done is just total up all the work done. Okay, and equate to the change in kinetic energy, and we can get the final kinetic energy as well as final velocity. Okay, so I hope you enjoy the lesson and you understand all the concepts. So please stay tuned for the next upcoming videos. Thank you. Bye bye.